So in 1.1, our topic is patterns and expressions. And like I've said, this is a little bit of review. And our goal for this lesson is to be able to identify and describe patterns and establish algebraic expressions to represent those patterns. We're going to skip this part right here and jump straight in to an example. So this first example is actually a display of toothpicks. I know it's a little bit hard to tell based on the picture. I'm going to use my colored pens. I like using colored pens so you can see things a little better. There are 4 toothpicks in the first figure. 1, 2, 3, 4. And so I'm going to fill that in the table. There are 4. My wheel just fell off. There we go. The next diagram has how many toothpicks? 8. And the next one? 12. Good. So the process column helps us think about how to get directly from the input number to the output number. So how could we get from a 1 to a 4, and a 2 to an 8, and a 3 to a 12, using the same rule each time? Madeline? Multiplying by 4. Great. So we're going to do 1 times 4, 2 times 4, 3 times 4. And we know that if we drew the 4th figure, we would do 4 times 4. We would see 16 toothpicks. And so ultimately our aim is to get to an algebraic expression that would represent any number of toothpicks. So that would be n times 4. Or we would write that as 4n. And then below here it says, write an algebraic expression that describes the number of toothpicks in the nth figure. Well, we did that in our chart, so we're just going to rewrite that expression, 4n. So now we know that if we were looking at the 100th figure, how many toothpicks would there be? 400. 4 times 100. Good. Next up we have tiles. And you can see here, we're going to make another table. Let you make your own table there to get some practice. And I'm just going to write input, process, and output. You'll be asked to do a couple questions like this on your Math Excel assignment. We have 3 figures here. And ultimately we want to be able to figure out the nth figure. So how many squares do we see in our first figure? See 4. And then what? 6. And then 8. And we could say what's next? What would be next? 4, 6, 8, 10, then 12, right? But we need to be able to get directly from input to output. So what's going on there? Could you think of a rule that would work for each one of these inputs to get directly to their outputs? 2 times n plus 2. That's it. Nice job. So 2 plus 2 times 1 is 4. And 2 plus 2 times 2. That's 4 plus 2, which is 6. 2 plus 2 times 3 gives us 8. And then 2 plus 2 times n. And so I'm just going to, that's a bad circle. It's 2 plus 2n is your algebraic expression. So it does ask us to figure out then how many tiles are there in the 25th figure. So we would do for the 25th figure 2 plus 2 times 25. Little refresher on order of operations. We do the multiplication before we do the addition. So that's 2 plus 50, 52. 52 tiles. Any questions so far? All right. We'll go ahead and fill in these blanks, and then we'll leave the rest to your video notes for Thursday's flex assignment. A mathematical quantity is anything that can be measured or counted. The value of the quantity is the first blank, quantity. Is its measure or the number of items that are counted. Quantities whose values do not change are called constants. In other situations, the value of a quantity can change. Quantities whose values change or vary are called variables. Yep. Variable quantities. So we'll go ahead and leave it there for today.